Okay, this is in-class exercise 5-3. We're going to draw a sloping berm, and the reason for this berm is to block the view from this platform here to the road here. And for the instructions, there's no swells or needed because we have an existing swell here that will take any water that comes from this berm. We have to block the view from this platform to the road, and this is an existing ridge line, so we just need to make it higher to block the view. The ridge line needs to be higher to block the line of sight. So with that, let's go ahead and get started. We can put elevation A is 118.5, and they say the eye height at point A is 5 feet, so we'd add 5 feet to this, which puts us at 123.5. So we'll just write 123.5. And then the height of the road for the vehicle on the road is 6 feet. So go ahead and move this out. So this is 123.5. And then down here, the road is 6 feet. So A, we just add, and the highest point of the road is the center line. Right, so that's the elevation we want to use. So we've got 120. We're going to add 6 feet to that, so this becomes 126, and we add 6 feet to this, it becomes elevation 129. We just added 6 to 123 and 6 to 120. So we have a person standing on this elevation 123. They're looking uphill at this road because this is 123.5. They're looking uphill to 126. Here they're looking uphill to 129. So it's higher right here, so the berm's going to need to be higher on this side than on this side. So the way we do that, we know what we want to do is figure out where we want to put the berm, which this is the highest point. See contour 123, so the highest point goes up 124, then it goes downhill. So the highest point of this berm is right here, and the highest point on this side is about right here. So we just put it in the center between, so we're just gonna, that makes it the easiest on us because that's the least amount of dirt we have to add. If we put it down here, we're lower, so we're going to have to go even higher. So that's why we picked those points. So now we've got to determine, remember, to block the view, we want to do a berm to the elevation here between these 2 points. We want to get to this elevation, and then we want to go an additional, 3 to 6 inches to get above that line of sight. This is the line of sight, here and here. So if we block everything in here, the person standing won't be able to see a 6-foot car on this road. So to do that, we need to figure out what this slope is of this line right here. So to do that, you just measure total distance. We know the vertical. We're going to do right here. We got to find out what the slope is of this line. Right, so slope equals horizontal times vertical. Horizontal, you just measure it with, oops, I got the architect scale, and this is engineer scale. So you measure with the engineer scale, and you get 125 feet total from this point along the line to this point, 125. Get that right on there, and that's right. The scale right? Yep, that scale's correct. So A to B is actually 127 feet. So 125, 6, 7. So this is 127 feet total. We'll just write this here to remind us. 127 feet total from here to here, and then from this side over here, if you measure it, it comes out to 126. 126. So this is 126 feet. So we know the horizontal. Let's do this side first. We know the horizontal. What's the vertical? Vertical is 126 minus 123.5, so 2.5 feet, right? 2.5 feet. You're looking up from 123, 24, 25, 26. 2.5 feet divided by 127 equals 2.5 divided by 127 equals 1.96. So it's 0.196%, which is, we can just round to the nearest hundredth. So that would be 0.2%. 0. Oops. Left a 0 off there. It's 0.0196, so round to the nearest hundredth would be 0.02, so 2%. So this is a 2% slope. It's going downhill this way, so we can either, now that we know it's 2% slope, we can figure out what this elevation is. If we measure this way, from here to here, it's about 53 feet. So we're going to try and figure out what our vertical is, right? Vertical equals what did I just do? Oh man, I messed. Slope doesn't equal horizontal times vertical. It's vertical divided by slope, which is what I did. Vertical divided by slope. Vertical equals horizontal times slope. I don't want to go back through and redo this video because I'm too far into it now. So hopefully you caught that. It's this, I said that calculation wrong. So vertical equals horizontal times slope. We said the horizontal is 53 feet. We're going to multiply that by 0.02, and that equals 53 times 0.02 equals 1.06. So we're measuring this way. It's going uphill, right? Because from 123 it's going uphill this way. So we got to add, I'm going to put 1.06. We've got to add 1.06 to this elevation here to get that elevation. So 1.06 plus 123.5, 124.56. So this is 124.56. Let's just add a half a foot, roughly. I mean, 3 to 6 inches. We want to go a little bit higher because that's the top. That's that would block the view. We want to go slightly higher because that's right at the top of the view. We want to go slightly over. So let's round this up to 125. So we'll make this, instead of 124.56, I'm just rounding up. If we went half a foot, it'd be slightly over 125. But let's just make it 125. That's elevation 125. And then over here, let's do the same thing. Let's calculate this slope, which we said it's 126 feet. And slope, we'll do it right this time. Slope equals vertical divided by horizontal. Vertical is 129 minus 123.5. So 129 minus 123.5. That gives us 5.5 feet of vertical. 5.5. And we're going to divide that by the 126, and that gives us, divided by 126, 0.04 0.043436. So we'll just go 4.4. It's 0.436507, so we're just going to round to, we can do 4% or we can do 4.4%. We'll just use 4.4%. Okay, so we'll use that number right there. Let's measure this distance from here to here. We're going to figure out what this elevation is here. We know what the slope is, 0.044. So what's the elevation? This is going from 123 uphill, so we're going to have to add to this number if we measure from here to here. That is approximately 41 feet. So we're doing a figure vertical, which is 41 feet times 0.044. So what does that equal? 41 times 0.044 equals 1.8. 1.8. So this elevation is 1.8 feet higher than this elevation, so we got to add 123.5. 123.5, we got to add 1.8 feet equals 125.3. So 125.3, we could, if this is 125.3, let's add, so it's 125.3 is the elevation. We can add a half a foot, and that puts us at 123.8. Let's just call it 123.8. So almost 126. All right, 125.8. Hopefully that makes sense. All we did, we got the slope, which we calculated, so then we just had we didn't have the vertical, but we had horizontal distance, and we had the slope, which we calculated, so we were able to get the vertical and just add it to this, and we got 125.8. So now we know what elevations we need to block that view. And all we've got to do now is draw our contour. So this is 125, so contour 125 hits there. This is 125.8, so 125.8, our maximum slope they set up above is 4 to 1. That's here, 4 to 1. So if this was 125.5, it'd have to be 2 feet away, because a half a foot at 4 to 1, just 2 feet, but this isn't even half a foot. So if we stay, I mean, you can just stay a couple feet away, and that's more than 4.1, right? Because we're only going to 126, 125.5. So 125 is going to go just on this side, right? 125. It's got to go around it because this is going up. So it goes like this and then hits there, comes back. So 125.1, elevation 125, and then it goes up to 125.8. Actually, it's almost 8 feet, almost a foot, right? 0.8, we're only 0.2. So this almost foot, we should almost be 4 feet away. So I should make that slightly bigger. So, because if this is almost 126, that's almost one, let's call it elevation 126, then it'd be 4 feet to have 125. So we'll draw like that. Now we're safe. So this is 125.8. This is 125. So we can label 125. And now we have a 4 to 1. Again, 4 to 1 maximum slope. All we gotta do is draw our contours 4 feet apart. And we're meeting the requirement of 4 and 4. So this contour goes like this, just drawing it parallel. This comes around, and this is 124, and this is 123. 124 is going to hook in. We're just going to go around like this. So 124 almost creates just a, so there's a, this is 124 here, this is 124, so this would be a little saddle where it's like 124, 123.5, so up to 124, up to one, that could be like a saddle, a low point between these. We don't need to connect 124, it'd just be more grading. So let's go ahead and draw 123. 123 is 4 feet apart. So now this is contour 124 or 123. Sorry, 123. This is contour 123. So all we've got to do is come around, tie into 123. So we have to do the same thing on this side, around until we hit 123. So there's that. We come around. And what we're doing here is we're drawing these at 4 to 1. So we've got a 4 to 1 slope. 125, 124. Here's 123. Let's label 123. We've got to draw, this is 121, so we've got to draw 122, 121. We got to put another contour 4 feet away. We have to keep going until we meet grade. So we'll just put another 4 feet away. Just do this. How's that? Draw it nice and straight. So 4 feet, this basically just needs to stay 4 feet away. That, this is 122. So 122 has to go around and hook into 122 right there. Same thing up here. 122, and now here's 121, so we've got to move 121 4 feet away, right, to meet the requirements of a 4 to 1 maximum slope. So we just do another 4 feet away, draw it like that. Same thing over here, 4 feet. So like that, and then tie into 121 over here. We tie into 121. So $121, and we just made a contour. Now we could, this is 121, so actually we didn't sorry, we did not need to go all the way around here. Let me show you. Like that, because here's 121 right here, right? So this could tie into here like that, and then if we wanted to make this a little nicer, we can pull this out away, so it could be something like this. We don't want to necessarily take out this tree right here, so we could just come around like that, tie in right there. So yeah, we can soften this slope just a little bit, so we could bring it something like this. So there you have it. This is 121, which we've tying back into right here. We have a 4 to 1 maximum slope, and we have a berm that goes high enough to block the view of the road. And that's it. It's a pretty simple exercise. Hopefully that makes sense. Just remember to tie in your contours. You just calculate your slope of these lines, and then you can figure out your vertical elevation, and then just draw your contours.